Yeah, tutorial video using GeoGebra and derivative graphs. So video kind of picks up right where the last one left off. So I want to make a graph of a piecewise function and its derivative. So the way you're going to input a piecewise function is going back to the input bar. Is you're going to type in f of x. You're going to redefine f of x, and the command is going to be if. And notice you have two options. You want to hit the second option, because you basically what it's saying is that if x is less than 1, it's going to graph this top one, and if x is greater than 1, it's going to, or equal to, it's going to graph the bottom one. So you want to type in, the condition is that if x is less than 1, you want it to graph the top equation, x to the third minus 3x squared plus 3x. If it's not, then you want to use the other one, which is x to the second minus 2x. So the way this interprets it is if x is less than 1, it's going to graph this. Otherwise, it's going to graph this, which is basically what a piecewise is. Okay, so once you have that, you go ahead and hit enter. And now you can rescale it, and you can see it's now your piecewise function. Now the way that GeoGebra kind of puts this out, instead of saying greater than 1 for the bottom part, like it does over here, it's just going to say otherwise, which is kind of what it means is like if it's not less than 1, then everything else is going to be greater than 1. Okay, so this is my piecewise function. Now one feature I do want to show you over here is that all these objects are hideable, meaning that, see how there's little bubbles next to all the objects? If I go ahead and click on one of the bubbles, it doesn't erase it, it just deselects it. So if I want to turn my tangent line off, let's say, I can deselect it. If I want to, for whatever reason, turn my function and hide it, I can deselect it and it'll hide it. It won't delete it, it just won't show it on the sketch. Alright, so there's my graph of the function. Now I want to graph also the derivative of this piecewise. So if you go to the tangent, if you go to the input, excuse me, and you're going to type in f and then the apostrophe prime and then parentheses x equal to, and then you're going to actually spell out the word derivative. And since it's a commonly used command, it's going to recognize it. And it's going to ask you what function do you want this to be the derivative of. So you want this to be the derivative of f of x. And you hit enter. And there's your derivative graph. Now let me kind of deselect the tangent line here. Now I want my derivative graph to kind of be different than my function graph. So I'm going to hit object properties. Let's go ahead and make it kind of reddish, maroon. Let's make it a little bit thicker. And then change the line style to be, let's say, a dashed line. So now there's your derivative, and it's, if I turn the function off, that's what the derivative graph looks like. Okay? So now I want to go ahead and make a text box to show the derivative's value. So sort of like I made the value for the function, I want to do the same thing to show the value of the derivative. So go ahead and go to the text box. Go ahead and hit LaTeX, and it's going to be derivative value equal to. Then go to the objects, and now you see there's f prime, and I want to evaluate this derivative at this x value. So you have to put parentheses and hit OK. You go ahead and object properties to make this a little bit bigger. Change it to maybe the same color as your derivative. It's maybe a little bit too big. Okay. Because now, if you notice, if I were to bring back my tangent line, right? Notice the slope in my tangent line is 4.4. and the derivative's value is 4.4. And if I go ahead and, let's say, move this over here, my slope at, let's say, my slope at 2.5 is equal to 3, and so is the derivative value equal to 3. And I can even confirm that by deselecting this. And if I drag this, you can see that at 2.5, the derivative at 2.5 is equal to 3. Right? So when I go over to 2.5, derivative, the red dotted line is equal to 3. Okay, so let me bring this all back here. That's one way of showing the derivative. Now, if you notice, when I kind of scale this stuff down, all the text boxes moved, kind of disappeared. So one thing you can do is, if you right-click on it, you can go to absolute position on screen. What that means is that no matter how I move the sketch, it's going to remain locked in that spot on the screen. Alright, the last thing I want to do is make a box that's going to show and hide the derivative and the point. So the last thing I want to do is under the slider menu, there is a show and hide box. Click on that. And I'm just going to go ahead and title it show derivative. Okay, so when I go ahead and I want to link this up to showing the derivative. So what I want to link this up to is I want to link this up to the function derivative, so f prime, and I also want to link it up to the text box that has the derivative value. So I want to link it up to text box number 2, and I go ahead and hit apply. And now what that does is anytime I click this box, it shows and hides the derivative. Okay. So it's a faster way than rather than having to click through these ones. It hides and shows multiple things at a time. All right, and that is the end of the tutorial.